So in this demonstration, I'm trying to show you how to use a gripper so that it can adjust the different sizes that it can grip based on a sort of force control. And then you're also using a callback function. All right. So let's do a little bit differently this time. So let's just use it, and then I explain the code afterwards. So let's see. Its code is already downloaded. So let's run it. I forgot. You see it's running, and we need to have a virtual controller also. So up will be opening it. D will be closing down. Okay. Up, close, up, up. Now I'm going to put a little bit of my finger here, and I'm going to close down on it. And you notice that it's trying to adjust itself here. So I could pick it up. Oh, a little bit too loose there. It's coming up. So we can force it up again. See how it opens up. It will adjust to different sizes, you can see. So if I can force it, let's say I have 2 fingers. It will adjust to the 2 fingers also. Okay. So you can see it's running and trying to adjust as best it can. So it feels like a child chomping on your fingers, essentially. Okay. So let's open it up. And let's stop the program. Okay. And let's explain the code. What does it do really here? So first, the code's still using that basic gripper motion file. So remember, page 1 to close the grip. Page 2 is open the grip. Page 3 is neutral pose. So motion index 1 is close the grip. Motion index 2 open the grip. Motion index 3 is a neutral pose. So, and let's see what the program does. So remember, the same servo again is ID 20. ID 20 here. Initialize the gripper. So call init grip control. Gripper speed 200. We set up the margin and the punch like regular. Gripping power, so the torque limit is 4. If you have this code, you can play with that. So the torque limit is 400. The gripper softness is 32. You can change that too, smaller or bigger. New one called the max squeeze force. I set up to 750. So remember, the torque limit maximum is 1023. So this is about 3/4 there. So adjustment 0. So first joint offset is 0. No, basically no joint offset at all. And then display motion 3, which is the neutral position. So that's what it does when it initializes. You see it opening up to the neutral position. Okay, and then went to a big endless loop as usual. And then it checked. If you receive the data from the remote controller, you pick it up. If it happened to be the U button, and then you set up the parameter called grip state to 2, and you call open gripper. And call open gripper is here. Basically, it's a no joint offset. Give a speed, a gripper speed, which was 200 here. And then just play motion 2, which is open the gripper. And then just wait until it's done. So it just opens it up. Nothing special there. If it happened to receive the data signal for, you push button 1 on the virtual remote controller. That grip state number 3, and initialize the gripper control again. So it goes through and reinitialize everything again. Now, the interesting part is this one. So if you push down the D button, it goes to grip state 1. But if you follow the logic of everything here, we should have call close the gripper, right? And just basically just play motion index 1. But in this example, we didn't do that. Okay, so instead of calling the close gripper in here in the endless loop, in this loop, we use a different way to achieve basically the same close gripper function. So we just do all we do is just set grip state 1 to the grip state, and then outside of the if you receive data or not, we have another one is if it's grip state 1, and then go ahead and play motion 1. The thing is with the close grip, all it does is actually just tell it to go to goal position 60. It have no how to adjust so that it adjusts to the force it receive. You cannot do that inside this main program. You have something that adjusts fairly fast. So what we do is we actually rely the actual force adjustment to a callback function, which is way down here. And remember, a callback function is executed every 8 milliseconds. So what does a callback? So think of it as this callback function will be executed every 8 milliseconds, essentially. So every time 8 milliseconds happen, it call here. And also it does it in parallel with the main program here. So the endless loop still working in here, but the callback in the background also is working. And you can see, so the main loop, you can see it just tell it to close, let's say, and then it keep on printing the data, the present position, what is the current joint offset, and what is the present load. But the callback is also executed every 8 milliseconds. And what does the callback function really do here? So first, it's zero. Every time it goes in, it zero out the average load, address 40. Okay, so address 40 is, if you remember, may not, address 40, if you go to the website for robotics, address 40 is the present load. Essentially, read the present load, save the present load, and then just check. If the present load is less than 128, it means very low. Basically, it didn't hit anything, didn't squeeze on anything, and then no problem, no adjustment, equals 0. If it's bigger than max squeeze torque, which was 750 here, that means it's really squeezing a little bit too hard here, and then it needs to drop it itself off, decrease itself by 1 every time it squeeze too much, decrease itself to 1. Okay, so you can see that if the load is light, go ahead and squeeze all the way. Don't worry about adjustment. Don't worry about joint offset. But if the load is higher, certain thing, ease off from it. Okay, and then so the if else if here is figure out the right adjustment, which is basically the joint offset to do. Okay, so hopefully that explains the thing better. So let's go back, and it's on now. So let's load it up again. And also you notice here the callback function is 60 byte and the maximum is 512 bytes. So it's very small program. You're not allowed to have much big. The main program you can see bigger, up to about 16 kilobyte. But the callback function is very small. Let's go to your output program. Let's move it here at the virtual controller. And then let's just play with it. So when it runs, it opens up and then it just stays like that. Okay, so let me put it here so you can see. So this is opens it up, and then this squeeze it down. Okay, you see it sometimes it's just funny there a little bit. So if I can force it open up temporarily and put my finger in there, and you can see adjust to my fingers. But if I force it and have a bigger two finger in there, it's still adjusting to it. I'm not squeezing too hard, so now it's adjusting for two. The thing is, if you look on the side, it opens itself up and down. Oop. So sometimes it just opens too much and then it slips out. Kind of crude way to do force control. Of course, more fancy manipulator in industry, they have much more better sensor and better algorithm here. So we're just learning. So we're trying to show you what we can do with whatever you're given, which is a joint offset features. And it's not bad. So we get something. You see it's really jumping around a lot now. Okay.